Hi everyone, welcome to IoT Show Deep Dive. In this episode, we are going to deep dive into developing for Azure Sphere. So this is a great event episode for you to watch, especially if you're a beginner, if you've never worked with Azure Sphere, or maybe you have a dev kit sitting in your office right now and you're wanting to get started but not sure what to do. This will be a great episode for you. And if you are already developing for Azure Sphere, I recommend staying and watching because we're going to be giving a lot of great tips, some best practices along the way, and you're going to definitely pick up some insights. And so we're excited to have you. And with all deep dives, they are live. So we do have the live Q&A. So depending on what type of questions you have, we are in chat. So feel free to ask those technical questions throughout the presentation. And then also, if you are viewing on demand, don't worry if you have questions while we're going through a full technical walkthrough. Feel free to ask those questions at some of these locations that we will give you, like IoT Tech Community, Microsoft Q&A, and we'll show you those locations at the end of the event. All right, so let's go ahead and get started. With all deep dives, I'm always really excited to bring in a new speaker who will actually go through this technical walkthrough with all of us. And so our guest speaker today is Richard. He is from the Azure Sphere team. Hi, Richard.
Hey, Pamela, how are you doing?
I'm doing great. Thank you for coming here and giving us this this walkthrough. Do you want to give a little bit more information on what you do here at Microsoft?
Sure. So I'm the PM lead for the Azure Sphere Customer Experiences team. So we're the team who look after the SDK that we're going to be talking about today, and some of the samples and reference solutions, and basically everything that helps you get going with Azure Sphere. So you'll also see us in other areas help with accelerating customers and demos that really show the power of what you can build with Azure Sphere.
Wonderful. All right, so I know we have a jam-packed session today, so let's go ahead and get started. So for the agenda, we are going to go over, what is Azure Sphere? So Richard, he's really going to lead this the whole way through, talk about what is Azure Sphere, why you would want to build devices on it, and probably spend about the first 10 minutes talking about that. And then after that, it's all hands-on. So we're going to be talking about, and showing you with a real dev kit how to clean your device, how to get it connected to Wi-Fi. We'll show the SDK. We'll show the different dev kits that you can get. We'll talk about tooling. And then Richard's going to go through a local deployment. He's going to talk about debugging, talk about the runtime platform, do a cloud deployment, and then also show how to connect to Azure IoT Hub or IoT Central. If you've worked with Hub and Central before, it's a little bit different experience to connect to those two services. So Richard's going to showcase how to do that. And then at the end, we'll close with resources. So let's go ahead and jump into it. All right, Richard, do you want to give an overview on what is Azure Sphere and then why developers would want to build their devices with Azure Sphere?
Absolutely. So Azure Sphere comes from us looking at what it takes to secure internet-connected devices. And when we looked at it, we realized that there were 7 properties that highly secured devices would need. And Azure Sphere is the only solution out there that gives you all of these 7 properties in one. And there's lots of information, I'm sure, will come in the resources that go through these in detail and why we have this belief and what we've learned along the way. So we won't spend a lot of time on this, but I will call out as we go through and look into the demo how some of these properties surface as you are developing with Azure Sphere. What we did realize in doing that meeting those 7 properties requires you to basically requires changes in your silicon, in chips, in the operating system that runs on those chips, and it requires services in the cloud. And again, you need all 3 of those to meet these 7 properties. So what we'll talk about today is obviously how all of those pieces come together in Azure Sphere as your single stop solution. So first of all, Azure Sphere, as it says here, defines a template for secure chips. So Microsoft obviously isn't a silicon manufacturer, but we work in close partnership with our partner silicon manufacturers to create Azure Sphere certified chips. The very first chip we have here is the MediaTek MT3620. So that's the one that will be on the dev kits we'll be playing at today. But obviously we're working with partners across the big silicon partners across the industry to bring other certified chips to market. Mm-hmm. So if we look at this today, we have just digging into the MT3620, there's all of these different pieces. It's a system on a chip and all the different cores and different aspects of the chip. And again, there's plenty of resources out there that go deep into what all of those do today. Today, we're really going to be concentrating on what happens on that ARM Cortex-A core, where our high-level operating system runs.
And then, Richard, you made a mention that the Azure Sphere team is working with the different partners, and that you mentioned the first chip, the MediaTek one. What about other MCUs? Do we have any in the pipeline right now? Is this the one that folks should start building with at this moment? What would be your recommendation?
Absolutely. So this is definitely the one to start building with at the moment and get your arms around what Azure Sphere can do for you. But as I say, there are more coming to market. So certainly we don't have detailed plans to share at this stage, given the nature of the industry. But we have announced that we're working in partnership with companies like NXP and Qualcomm to bring Azure Sphere chips to market. And so in our future, we see there being Azure Sphere certified chips that are for every use case, every price point, every feature that you might want, and there'll be a whole ecosystem of these chips. So on to the Azure Sphere operating system, and so that's running on what we call the high-level core on the system on a chip. And this is the operating system and the software stack that will handle all of the internet connected communications, where it's so important for everything to be as secure as it can be. So again, I'm not going to go through all of these stacks in details. There are resources and talks by many of my colleagues that go into a lot of depth here, but just give you a sense that building on the chip, then we have our trusted computing base called the Pluton runtime. And then we have various levels of the operating, including our custom Linux kernel, and then sort of on-chip, on-device services that are running on top of that, and then all leading to essentially a secure sandbox for your apps to run. So both we have what we call our POSIX apps running on the A core, and that's where we're going to be spending most of our focus today. But also you can run your code on the real-time core, so those on some of the Cortex-M cores on the MT3620, where you might handle some of your real-time needs. So we'll look at that a little bit in a moment, but mostly, again, there are resources. I know that you've recorded videos with some of the other team members on the Azure Sphere team looking at what we can do on that core. So, and then the third piece of the puzzle, so we've talked about the chip and the operating system that's providing the sandbox. We have the Azure Sphere Security Service that connects and protects every Azure Sphere device. So again, we'll talk about how you interact with that service quite a lot as we go through today. But one of the key things this is doing is allowing, basically asking the device to run various tests, what we call attestation that it's up to date and running the right software. And then only if it is, then it's issued with a short-lived device certificate, which then can be used to present to you, it be Azure IoT or your own backend services, where that means those backend services will know that the device is up to date, it's legitimate, it's secure, it is secured. So we'll talk a little bit about how you can set up and get going with that in a moment. And then finally, obviously, what we're really here to talk about is all of the developer story that sits around this. So the Azure Sphere development tools and sample software. So if you look, essentially, there's always this triangle going on of what's running on the PC, what's running on the device itself, of course, and what's running in the cloud. So on the PC, as we're going to show, of course, we have our Azure Sphere SDK, and that contains all of the tools you need to build your Azure Sphere device. as well as the command line interface we're going to be using to talk both locally to the device that's attached, the dev kit in this case, as well as to talk to the cloud. And then we also have some great Visual Studio and Visual Studio Code extensions to make a really sort of seamless IDE experience as well. And then what you're doing with SDK, of course, is building your apps that run on the Azure Sphere OS and are using both the Azure Sphere libraries, the built-in C POSIX libraries we have, and the Azure IoT C library for talking to Azure IoT Hub or IoT Central. And as well, of course, as we've discussed, you can be running these sort of real-time capable apps as well. And then we have, as it's showing there on the right, a whole bunch of resources. Obviously, we have our documentation, and we'll be pointing out where to get started with that. But we also have some great sample apps and reference solutions on GitHub, which can really sort of bootstrap your development with Azure Sphere and get you off to a flying start.
I'm going to call out a couple things on this slide. One of them being, if you worked with our SDKs before, the Azure IoT SDKs, you notice that there's the C SDK, but we also announced the embedded SDK for C, and that is now in public preview. It's meant for constrained devices, but what Richard is showing here is support for our Azure IoT C SDK, but we are in talks, the teams together, on the support for embedded C SDK, for potential support there. But just to let you know and call that out, that that is our normal Azure IoT C SDK that we've had around for a while now. And then Richard had a question about your, I see, VS Code extensions. Do you have, it's also for Visual Studio itself, you have support there, the same level of support as you have for VS Code?
Yes, absolutely. Basically, everything you see today, which I'll be using Visual Studio Code today, but everything you see me do with Visual Studio Code, you could do with Visual Studio as well.
Okay, perfect. I get that question a lot because I know for Azure IoT, we did a lot of support for VS Code in the beginning, and now we have the same support for both if you're going for Visual Studio and Visual Studio Code. The last thing I'll point out is for folks, if you are interested in Richard's call out on the Azure RTOS, we did do an IoT show episode where we talked about kind of that better together story with Azure Sphere and Azure RTOS, and talked about when you have them together, how it can help you quickly build these secure IoT devices that needs those real-time capabilities. And so definitely check that out. We'll put a link in the description if you're interested in that. All right, so I think we are ready to get on to the hands-on part. So if I'm a developer, I got the board in hand, or looking for a board, Richard, could you give us a little bit of overview on, some of the dev kits or the tooling, or just how to get started? The first things that I would need to build with Azure Sphere.
Sure. So I guess the first thing you're going to need is a dev kit, like you say. So right now there are these 3 dev kits you can see on screen here. So you can come to this site here and then pick the dev kit that best suits your needs. Today I'm going to be using the Seed Azure Sphere MT3620 development kit, sometimes called the RDB because it implements Microsoft's reference development board design. So
sorry, Richard. I'm just going to jump in and say, what I love about these dev kits is that for even the Azure Sphere one, for the Seed Studio, they have headers for Shield for the Grove line. And the Grove line is super nice to easily connect popular sensors. And the AvNet Azure Sphere dev kit has the Grove extension connector on there. So you can easily connect sensors to I2C. Just for those who are interested in how do I connect sensors to these dev boards.
Awesome. So once you've got your dev kit, then obviously the next thing you do is get your SDK installed. So obviously we have SDKs for Windows, which I'm using today, but we also have an SDK for Linux currently with Ubuntu support, but also looking at other distros in future. And then you've got the option here, as we were just discussing, do you want to be developing with Visual Studio Code, or actually do you want to work directly with the CLI and integrate that with the tools you're currently using? So you have those options. So what I'm going to do today is just talk through quickly what would have happened, the steps to get things installed. Obviously, I have them installed already today because we don't want to wait to see that all happen. But basically, you're plugging in your dev kit, you're installing the SDK, and then you're also installing these two key tools that we need as well. So there's CMake and there's Ninja, which are, again, for those familiar with them, basically build system tools that we use to allow us to build the same Azure Sphere app, be it on Windows or Linux, or a high-level app or an RT app, or in any of Visual Studio Code. It's supported across the board, so that's why it's a great solution to use there. And then, of course, if you're using Visual Studio Code, you want to go install the extension. So basically, the steps here on the right, I've gone through those, and once you get there, this is what you'll see. In particular, you'll have your Azure Sphere extension here, and as well as that will have pulled in the CMake extension that's needed too. So you can see actually here it's already saying that it's found a device and there's a device attached, and actually you can see that I've got a dev kit attached on the screen there. And then the other thing that the SDK installs is what we call the Azure Sphere Developer Command Prompt. So if I just I've got it pinned here, but I will just show you it on the start menu. That's how you can find it straight after install. And that brings up this prompt. I think one of them will do, we don't need two. And away we go. So we have that, and then just the very first thing to type here is something like this, which will show the dev kit is attached, and I imagine that won't work because I have not plugged it in the right way. So if you just give me 2 moments, then we will do that. Oh no, there we go.
Yeah, step one.
While I'm busy fiddling with it, it's already worked. So that says my device is running the Azure Sphere, the latest version of the Azure Sphere OS 2006. So that's a great first step. I'm installed. I can talk to my local device. But if I have any trouble, so come to some of these troubleshooting guides here, and that will talk me through some of the things that might go wrong and what I might be able to do to fix it.
And I can imagine, so you have the tooling, everything's installed, but right out of the box, it's not going to be connected to Wi-Fi, or the device won't be claimed. Could you walk through that experience of claiming your Azure Sphere and what that actually means? And then how do you get it connected to Wi-Fi?
Sure, totally can do that. So the reason you need to claim a device, and it's worth, I think, just spending a moment on that, because it's really, again, part of the big security story around Azure Sphere, is it's basically proving that you are the owner of this device, and then you're entitled to run your own software on this. So it allows you basically the ability to obviously push software to it from the cloud, or as we're going to be doing today, actually install development capabilities on it. Because ordinarily a device, an Azure Sphere device in the field, you certainly can't just attach to it and start running software on it. But that's what we need to enable in development terms. So that's why we've got to claim things. Now, claim is a one-time operation. So again, I can't actually show you that happen right now because naturally I've claimed my device before, but it's as simple as typing this. But before I can even do that, the chances are I'm going to have to log in first. So I'm going to do an Azsphere login. And you can use any Microsoft account, so any corporate or personal account for this. So I'm going to use this account here. And now I'm signed into Azure Sphere, and it's important to note this sign-in is not quite the same as a sign-in to an Azure subscription. Right now, Azure Sphere logins are sort of managed separately to the side of the Azure subscriptions that we'll use when we're talking to IoT Hub and so on. So I'll come back to that point in a moment. So,
and Richard, just to jump in here, could you increase can you zoom in? Because I think it's
yeah, that's maybe not a bad idea.
I'm squinting over here, Richard.
You got it. What do you reckon? Is that going to do the job?
Yeah, that's better.
What a great idea.
And to add to your mention about claiming being that one-time operation, I get this question a lot from folks where they say, all right, I have this kit, I've claimed it, and now I have another person I want to give this kit to, or maybe they want to transfer it to another organization. But just to be clear, the device can only be claimed once, and once it's claimed, the device is really permanently associated to the Azure Sphere tenant. So just keep that in mind.
Sure, yeah, that's an important point to bear in mind. Certainly, as a developer, naturally, it's less of a problem when you're building real devices that would go out into the field. But it is something we've heard, and I believe that, please go and upvote that on our user voice, because I know that's something we'll be looking at in future. So just to walk through again some of the steps that have led up to that claim operation. So now I've logged in. Now, again, I already have a tenant today. So a tenant is essentially an isolation group for a bunch of Azure Sphere devices that I am managing. It gives me the sort of control over that. So I already have that. If I didn't have a tenant, I would write Azure Sphere tenant create, and I think I would probably give it a name. And again, you can only use, each device can only be used to seed one tenant. So again, we just make sure there's a throttle on that and make sure people aren't just creating lots and lots of tenants. That device can only be used once. So again, that's not something I can show directly. But once you've created it, of course, then you can see the tenants that your current login has access to by doing Azure Sphere tenant list. And that will show me, hey, I just at the moment have this one tenant, but if I had multiple, I can select the tenant. There's Azure Sphere tenant select, and I can make sure that I'm pointing at a tenant, because almost all the remaining commands I'm going to do, certainly when talking to the cloud, will be at the scope of that tenant. So it's at that point that I'm really ready to do Azure Sphere device claim, if I hadn't done that already, which I have. So up to prove that point, a good command to type is something like Azure Sphere show deployment status. And that's going to show both what's on the board right now, as we know it's 2006, but also the Azure Sphere Security Service is targeting this device with that OS. And if I hadn't claimed the device, or I was logged in with the wrong account, then it would complain that Azure Sphere, the security certainly isn't going to tell me about that because I'm not authorized. So I'm claimed at this point. And then I think you also asked about connecting to Wi-Fi. So you might well find, if you've got a new dev kit, of course, it will be currently running an older version of the OS. So, of course, the first thing you need to do is get yourself online, so then that can be upgraded over the air to the latest. So again, there's commands here, as a bunch of Azure Sphere device Wi-Fi commands. You can do Azure Sphere device add something like this, your SSD, and then the password, and that would add that. Again, I'm not going to type my home network password to you all right now, so instead I will show you that I am already connected to it. And that's the command that proves that. We have had a few people say that when they're connected, it's connected to Wi-Fi, but you may be on a captured network or whatever the case may be, but you haven't got full internet connection. So it's coming soon in a future release. There'll be additional commands that will give you sort of insight as to actually what the internet connectivity is like. And there's troubleshooting guide to do that right now, but this will be a simple command is coming that way.
That was great, Richard. And could you show us, now that we have the device claimed, it's connected to Wi-Fi, maybe let's start building an app. Could you dig into what is that experience, and then also debugging too?
Sure, yeah, that's what we're here for. So the very first thing I want to do is Azure Sphere device enable development. So this is a command that's actually going to do a bunch of things, and while it's running, it's probably going to give out a lot of output, but I'll try and summarize what it's doing, because it's doing three important things. The first thing it's doing is getting what's called a device capability file from the cloud, and I'm only allowed to get that because I own the device, because I claimed it. That's part of the security story. And now that gets side-loaded onto the device, and then the operating system is going to recognize that and allow me to do a bunch of local things like locally debug apps and locally deploy apps, which obviously you wouldn't be able to do with an ordinary production device. The second thing it's going to do, and it's doing it right now, is install GDB server. So that's the debug server onto the device. And then the third thing it's done is tell the cloud not to deploy apps to this device. So it will still deploy the operating system to the device, but it's not going to update apps, because otherwise, as soon as I deploy a local app, the cloud will come along and stomp on it again, which won't get us very far. So it's those are the three things that command has done. And so once I've done that, I'm ready to then go and follow, maybe cover this. So I'm now at this point here of building a high-level application. So I've done the preparation about enable development. So the next thing I need to do is get my first app. In this case, if you're following this, it will suggest you clone the Azure Sphere samples repo, which I've already done here, and then open the Hello World app. In this case, actually, I've chosen one of the other sample apps because it's just going to speed us along a little bit more quickly. So I've chosen the GPO high-level app. So this is an app that just demonstrates the GPIO, the general purpose input-output capabilities of the device. So now I've got that open in Visual Studio. I can open it up, and in fact, one of the things I should do is just take a look at the README, maybe in a slightly more friendly format, and then that would give me all of the steps I would need and a bit of information about this app and why I'm doing it. So let's, first things first, let's do a rebuild of this app and see what's happening at the bottom here. So in the output panel here, and I've chosen CMake build, you can see CMake is busy doing its thing and cleaning up and then executing the build commands to build my app. So, sometimes it's important, you can see sometimes, and we'll see a few of these, some interesting error messages or warnings in this. It's always good just to take a look at this and check that it's doing what you would expect. But essentially it's compiled my app, created the binary and wrapped it in an image package is what we're going to put across to the device. So we'll come back to the ways I can use that later when going to the cloud too. So now I've built my app. Let's hit F5 and get it onto the device itself. So let's just make sure I've chosen the right app to do that. And so now I'm going to just use the built-in, again, Visual Studio. It's all integrated with via the Visual Studio Code extension, the F5 deployment and debugging straight from your IDE. So again, now you can see output this time from the Azure Sphere extension that's telling me I'm deploying the image. And again, it's always good to be keeping an eye on what Azure Sphere extension is telling you and what it's doing here. So it's actually saying, hey, I'm talking to the debug server, I'm running this app under the debugger. And what you'll notice in a moment actually is it will jump over to the debug console and give me a bunch of information about that. And if it does that, it may not do that today, actually it hasn't. If it does, it's always important just to click back to output if you want to just see what's coming directly from the app. So maybe let me just give a quick demo of what this app does. So I'm hoping you can see on my screen, I'm not sure I can see it myself, so you let me know if you can see it, that you can see my dev kit here. That might make it a bit clearer. There we go, yes, we can see it. There we go. Right, so you can see that basically this app is busy flashing away that LED. And if I press this button, what that does is just slow down the frequency of the blinking. I press it again, it slows it down some more, and I press it again, and it's gone back to the original frequency. So it's as simple as that. And then the other thing I can do is, of course, go into, because I'm running under a debugger, I can jump into the code here, and I can put a breakpoint. Let's put a breakpoint here whenever I notice the button's changed. Press time, and immediately, great, that I've hit the debugger, and actually you've got all the great things you expect in Visual Studio Code, what's going on in terms of the variables and the stack and so on, and I can debug my heart out from there.
And Richard, do you want to give us kind of a tour of the code, the sample that you're showing right now, and then highlight some parts that are important for us developers that we should know when creating our own applications for Azure Sphere?
Sure, I can do that. And just as I do that, let's click back here. And actually, I think something I probably should have mentioned earlier is just the way I've opened these in Visual Studio Code. I've made sure to open the folder at the right level containing the sort of the VS Code or the VS project files. If you open the whole samples repo at root in VS Code, then I think CMake will kick in and try and build all 20 apps at once or something like that. And it really doesn't end very well. So just make sure to use the sort of the file open folder at the right level when you're opening it up. So I've done that ahead of time to create this workspace for this show, but obviously that's what you'd want to do at home. So yeah, you said let's jump in and take a look at what we've got in the code. So let's spin through main.c. So right at the bottom here, I have my usual main, which is basically in doing some initialization we'll look at and running an event loop. And if I then go up and look at that initialization, it's doing a bunch of things which we'll talk about in a bit more detail. But the first thing I want to call out is just that I'm basically have got, standard POSIX-C functions like memset. And actually, let's just take a quick look at where that's coming from. So that's coming from the SDK, and it's coming from a sysroot. And I'll talk about the different versions of sysroots a little bit later. But basically, here are all the include files that I can incorporate. And if you look on, it's explained online, there is a set of APIs. Not everything you might expect to see is available. For example, you can't open an arbitrary file on the filing system. This is all part of both the security story, but also part of our sort of compatibility story of making sure that we can deliver on our promise that if you build an app and deploy it on Azure Sphere, we can update the operating system under you for many years to come. So we've been very thoughtful about what's included and what isn't, but you can take a look at these include files to see what's there. And then the other thing to look at is just as an example, this is the command that's just opening the GPIO for the button that we're using. And again, if I just take a look at that, again, that's coming from, this time from what we call applibs. And these are the Azure Sphere specific APIs that we were talking about earlier for doing things like manipulating peripherals or other Azure Sphere functions. So the other thing then to probably look at is to look at how we're actually sort of abstracting the hardware we're using here. If we look up here, we can see that we're including sample hardware.h. So all of these sample apps work on essentially this abstraction. You can maybe, and in fact you'll see us, I think we're going to change this to be called sample appliance.h soon. It's basically the conceit, the idea is it's running on this sample appliance, and that sample appliance could be running on any type of hardware we support or any board we support. So let's take a look now. If I just spin back to that initialization code, if I just look at the definition for this, I can see that this sample button is running on the RDB button A. Now, if I was running on a different dev kit, I would be pulling in a different implementation of sample hardware.h that pointed at a different button, whatever the correct button is on the different dev kit. And just for a good measure, let's just quickly look at the definition of that. In turn, this is the definition. So this is a board-specific definition that is defining all of the things this board has to offer, all of the buttons or the LEDs, and it defines them in terms of the underlying pins on the chip itself. And so now we're starting to get to the bottom of the hierarchy here. This is the definition of all of the pins that are on the MT3620 chip itself. So if I pop back here, what we'll do is we'll just take a look at some of the other parts of the app structure here. And one place to start is to look at cmakelist.txt. And what you'll see here is this is setting up what hardware definition this app is running on. So if I wanted to just run this sample app on a different hardware, I can just replace this here, and I forget what the directory name is. I don't think there's autocomplete on it, but if I'm running on the AVNet dev kit, you can soon find out the directory that I want to use there. The other thing I might want to do is, now I'm starting to write my own app, is just directly target the next level down. So directly target that board-specific definition that I looked at a minute ago, and just directly write my code in terms of the LEDs and buttons that are on that board. So if to do that, if this one does complete, that's great. And then if I go back to main, I will change this so I'm now directly targeting, instead of using that sample appliance abstraction, I'm just directly targeting the RDB board that I'm running on. And then, oh, look, everything's gone red here. That's not surprising because I'm still using things that I'm no longer including. So what I can do here is just update that to let's target the things that are directly on this board, which is a useful thing to do. So I probably want to do something like this. And let's choose the green LED instead. And let's also, oh, of course, that was the button. So that wasn't very clever of me. Let's choose a button instead. Let me just unwind that for a moment. We'll try that one more time. That's better. Let's just directly target the button, and let's do what I was trying to do a minute ago and target the there we go. I can just type this, I think. And as I say, let's choose the green one here. So let's now we've retargeted the app just to directly do that. Let's see if we can rebuild the app. So what's interesting is that start. That's because the first reason that failed is because I was still debugging the old app. So let's just press stop there and do a clean rebuild at that point. So that's going to carry on compile all my files, but I'm predicting we might still hit a bit of a problem. Yes, we did. So we hit a problem and it's a little bit hard because it's scrolled off the screen. But when we were packaging it, here we go. This is the key message here. So it's always important just to skim through these messages carefully. And it's saying that I couldn't map these peripheral names in the app manifest. So that now leads us to look at another file, which is the app manifest. And this is a key security feature of the platform that's worth a moment talking about. So in the app manifest, I have to declare which peripherals I'm using. So even if a hacker comes along and somehow does manage to own my app, they can't, and somehow they change the code much in the same way, and obviously at runtime, that I was doing there to use a different peripheral and try and use a different heating element or whatever was on my device. They can't do it because this app doesn't have the rights to use that peripheral. So I have to also go and update this app manifest to match what I've done. Let's do that. Like so. And try one more time. This time I think rather than just doing a complete rebuild, let's see if I can just build from here and see if it is happy with me. It's built in the app this time, and it's already going to try and deploy this. And with a bit of luck, we'll see. We do. I hope you can see now the LED is flashing green. So I've done a bunch of things there in doing that. And I think I've just stopped it myself, or maybe I think it's just firing up the debugger and then it will start it up again in a moment. But what I've done there is get us going, there we go, on directly using the hardware definitions for that board. There's one more thing to show you in CMake list.txt. There's a lot of features here to tour through, and that's this line here around the target API set. So typically each quarterly release or so, we add new APIs into the API set. So, in the next release, it will probably be API set 6. You can take advantage of those new features, but equally, if you have shipped a binary that targets the current API set, then we're going to support that for years to come. But to just give you an idea of how to change that targeting, let me just change this to 3 here. And if I do that, I know that I actually also have to change it in a second place because I'm using in Visual Studio Code. So I'll change this value here to 3. Again, there's lots of details about this online as to exactly the sort of syntax and why I'm doing this. But the interesting thing now is if I try and rebuild now, again, I think I'm going to cause myself some trouble because I'm trying to use things that exist in level 3 indeed. So I've got all of these compile errors, and that's because the event loop facilities were added in API set 4. So I think that is a quick tour. I'm not sure how quick it was, but there's, as I say, there's a lot going on that's important. This is to call out the differences for building maybe a regular app on a platform you might be used to.
Yeah, Richard, this was a great tour. Appreciate it. And then now that the app is ready, well, you might need to change the version that you were setting it to. But now that the app is ready, how do you deploy it via the cloud?
Sure, you're right. So the first thing I should probably do is change things back.
Maybe to latest or something. Yeah.
There we go. So it's back to how it was. And then, yeah, absolutely. So now I've built this app, and this is what Azure Sphere is for, of course, deploying apps at scale via the cloud. Again, what I'm going to be doing here is kind of following of the guidance that's here. So I'm going to be following the steps that you can come back and sort of see offline at your leisure here in terms of creating my cloud deployment. A lot of the setup for cloud deployments is done through the CLI right now. So the way you think about deploying apps is there's basically each tenant has a set of products, where products are things like a coffee maker or a dishwasher or whatever, our IoT cliche is. But of course they could be blood pressure monitors or all of the other applications that we know. And then each product has a set of device groups, and that you can use to sort of segment the different instances of that product. So let me just show you how you can set this all up yourself, but I'm just going to show you what I've got already here. So if I look at do Azure Sphere product list, that's going to show me all of the products in my tenant. I have this coffee maker product, and if I do this, I can see, I think I have to type, let's see if I got that syntax right off the top of my memory. Yep, there we go. And here are all the device groups within that product. So in particular, there are these 5 default device groups: development, field test, and production, and some additional ones for OS evaluation. And just briefly on that, that's for allowing you to, if every time we ship a new OS, we ship it to our evaluation feed a couple of weeks early, so you can have a sanity check just to check that we have indeed not broken anything your app relies on, and gives you the opportunity to give us feedback if that's the case. So what I'm going to do now is, well, probably show you one more thing, is just to show you that this particular device, what does the cloud know about it? So this command here, you can provide the ID of any device in your tenants. You don't have to have an attached device to run this command, but what's happening is it's saving me the typing by picking up the ID from my attached board and then passing that ID to the cloud. And the cloud says, hey, I know about this device. Its product is coffee maker, and it's in device group called development right now. So the next thing I want to do is then enable cloud test on this device. So this is basically the opposite of the enable development command that I did a little bit earlier. So that's going to do a bunch of things which are the opposite. So it's actually now removing applications to the device and the debug server. It's also essentially it's removing that special capability file that I talked about earlier that allows you to do debugging. Now actually the way it works is it just installs an empty one instead that confers no special capabilities. This device is now essentially back in sort of production mode, and you can't attach things to it or do any local debugging on it. And by default, because I didn't tell it otherwise, it's moved it into this device group called field test. And what's interesting, you can see it started there, and that's actually probably an app that I deployed earlier to this. So let's see if we can show you how that works and go through that cycle. So let me pop back to the app, and let's check that we're looking good. I hope we're not complaining about things. Oh, I think the thing we should do, just to make it really clear that we've changed it, let's go back and change this one more time to something like the blue LED. There we go. And I've got to remember, of course, I've got to do the same thing here. And what I'll do also, I'm going to change the name of this app to blue here. So this is just these names and this component ID are essentially just identifiers for the app. So that will allow me to reason about this app and identify it when it's pushed to the cloud a little bit later. So let's just see if I can just do a clean read. I think I retargeted everything. So hopefully it's going to rebuild that. And it's going to give me, say, this image package. And this image package is the thing I'm going to give to the cloud. And the cloud is then going to deploy that to device. So here we go. Great. Here it is. Here's where my image package is. And I'm going to now deploy that. So how do I do that? I come back to my command prompt and I do this. And I am going to have, here's the tip, I can't remember the syntax. Magic tip, just do this and to get yourself a healthy reminder of what the syntax is. So what I need to do here is say it's a deployment for the product called Coffee Maker, and it's for the product name. And it's for the device group called Field Test. If you remember, that's what my device is in. And I want to give it the image package that I just grabbed. So you can see what we're doing here is uploading to the cloud this image package labeled blue, just to keep it different. And I can also then run a little command here just to see what the cloud is now thinks this device should be running. That's not right, but that is. And this should tell me that the cloud is indeed trying to deploy the blue app to my device. So it's, as you can see, already flashing. It's actually a little hard on the screen to tell whether it's green or blue given the way the video is recording. But to make certain it's picking up the right app, you sometimes have to just press the reset button. So normally devices check for updates every 24 hours, but we haven't got 24 hours. So what we can do just to make sure is press the device, and if we wait a few seconds after that, then every time it starts up from a restart, it does check whether there's a new app. So there we go. That's how we deploy a new app to this device.
All right, now to my favorite part is talking about Azure IoT Hub. So I might be biased as I'm on that product team, but I know we have tons of great samples, resources, tutorials on connecting to IoT Hub and IoT Central. Do you want to go through that experience of connecting those both ways? And for those who are viewing who this might be the first time you're hearing about Azure IoT Hub, it's our cloud gateway. Think of it as that way where you could do bi-directional communication with your device and Azure. And then IoT Central, it's really that Microsoft's answer to having a service, which is a IoT application service platform to be able to manage devices and be able to visualize it, do analytics, control those devices. So yeah, Richard, do you want to kind of show that experience, and then we can showcase where they can actually find those resources?
Absolutely, be happy to. So what I'm going to do, again, let's just show you the instructions online that I'll be trying to do a quick summary of. So there's kind of two things you need to do just to get Azure Sphere working alongside Azure Sphere, Azure IoT Hub or Azure IoT Central. So the first thing you need to do is set up essentially the cloud-to-cloud trust between the different services. So I'm not going to go through that in a lot of detail given the time we've got here, but again, there's a sort of summary of the steps here. I can obviously set up my IoT Hub and my DPS, which I have in the portal. I'm going to go there in a moment. And then, in fact, let me just start that loading now while I keep talking. What I then need to do is download let's see, I suspect I need to use this one. I then need to download a certificate from Azure Sphere, well, basically a certificate authority certificate. So as we discussed earlier, each device is issued with a shortlist certificate every so often after Azure Sphere Security Service has checked that it's okay. Now that device certificate is chained up to a certificate authority at the scope of your tenant. So what the great thing about that is your IoT Hub, IoT Central, or your own backend service doesn't need to know ahead of time about all your devices. When it sees a new device, if it chains up to that certificate authority, it knows it's legit, it's one of your devices. So again, I'm not going to go into all the details here, but if I just look at these commands here, you can see I've got commands such as download CA certificate and download validation certificate. Now, it's important to note, I think in a coming release, these commands are going to be renamed and moved to a different place, but basically they're going to do the same thing, so you'll find them. And what I want to do is use those when I'm in the portal, especially with DPS. So DPS, as you know, is our device provisioning service that sort of sits in front of the hubs and points your devices when they arrive at the right hub. So what I've done, and again I did this earlier, is grab this certificate from my Azure Sphere tenant. I uploaded it here, and then I basically validated it. So there was a process, it's already verified, but there was a process whereby I create a challenge code here, and then I give that back to Azure Sphere Security Service, and it then gives me another validation certificate. So that's proving not just that I know, what the tenant is, but I am currently in possession of that tenant and have ownership over it. And then the other thing I need to do here is go to manage enrollments, and I need to set up this to say, when a device comes in that's signed by that CA certificate, where do I need to send it? And right now I've just kept it simple to Hub, and that's where all my devices are going to go. So that's the cloud setup that I did here. And then the other thing I need to do is then grab my sample app. So actually I should have shown you, I talked about cloning the samples app earlier. This is the repo on GitHub where they're all coming from. And in particular here, I've got the Azure IoT sample app. So actually if I just click here for a moment, you can see there's an overall README, and then there are links at the bottom for how to run it if you're using Azure IoT Hub or how to use Central. So I'm using Hub right now, so I'm going to click on that and then follow these instructions. And again, those are what I'm going to show you just live right now, but they're there for you to follow later. So if I come to, let's close things down here and go to that sample. And I have to do a few things. Again, I'm back with the app manifest, and the app manifest is just, again, so important to our security story. So a couple of things I have to do. First of all, actually, the first thing I need to do is grab my DPS scope ID. So I think I can grab that from here, and I'm just going to tell the app there because it needs to know which DPS instance I need to talk to. So let's do that. But then most importantly, then there are these allowed connections in the manifest. And what this is telling essentially this is telling the OS that this app is only allowed to talk to these domains. So again, if I get owned, this app gets owned, the app can try and make requests to whatever domain. Maybe it's trying to create a botnet out of my device and go and use it to do some denial of service attack against Microsoft, for that matter. But if Microsoft.com isn't in this list, then this app can't talk to it. So it's important I have to stick in the URLs of the hubs I want to talk to. So this is the DPS URL that's already pre-populated when I cloned the app. But I do need to go and add the IoT Hub URL that I had. So let's do that. Make sure I can talk to it. And then the other thing I need to do is update this device authentication field. And this says this app is only allowed to work with this particular tenant. So my tenant in this case. So again, if for some reason this device gets owned, it can't go and pretend that it belongs to a different tenant and go get access to another company's IoT hub or services. Or more importantly, it can't get the certificate issued in the first place from anything but this tenant. So I have to get my tenant ID. Let's just do that. Actually, I can do it here. Grab the tenant ID and put it in here. So now I've done that, I need to also come back here one more time, I guess, because I'm doing local development. So I better do Azure device enable development again and let that do its thing. And then when it's done that, then we'll be able to deploy this app and watch it talk to IoT Hub. And as I say, it would be a very similar process if I was using IoT Central, except, obviously I would have used, there's a place in the central UI where I can get the information I need. And there's also a special tool that's in the GitHub sample repo that gives you some of the other information you need in terms of, I think, finding your scope ID and your hub URLs. That helps you fill that all in. So great, that's enabled. So I think I can come back here, and then let's just see, again, make sure I'm targeting the right app and see if I can build and run that. And what we're going to do here while we're connected, we're also hopefully going to be able to make use of the IoT Hub VS Code extension, which is connected to my hub, and we're able to just see information about that, and actually hopefully we're going to be able to use this to sort of monitor what this device is doing in a moment. So if we look at the debug output here from Azure Sphere, we can see we're just about the app, and I think we'll see some information about just how it's getting on in connecting to IoT Hub in just a moment. There we go, it started up, it's opening the buttons, it's registered the DPS scope ID it needs, and the good news is this is saying that everything's been okay when talking to DPS, and this device has sort of managed to talk to DPS and is now pointed at the correct hub. And we might come back to that in a second, because there are some things we can do if we get the manifest wrong that will result in errors and those things not working out okay. So this is sitting here sending some telemetry every few seconds, just obviously some simulated telemetry from this device to my hub. So if I come back here and let's refresh this device here, it's gone green, that's great, it's connected to IoT Hub. And if I do this, I can now see, and I'm now in obviously look the hub's output, and it's receiving all of this information matching what is being sent from Azure Sphere right now. This is the same data being sent. So everything's connected. Just to give you one more illustration of that, I could go and edit the device twin. So again, I'm sure you've got plenty of IoT videos before that have talked us through how these things all work. But so very quickly, I've just got this idea of a status LED here. And if I change the twin to true and then push that change to the twin, with a bit of luck, if you are looking at the device, that LED comes on. So that's great. I think that's basically talked through everything about how we get connected to Hub and Central. But I think just to really land some of the key security points and what I'm getting with Azure Sphere, I thought I'd do a quick experiment where I get some things wrong here and show what happens. So the first thing I'm going to do is if, for whatever reason, I had the wrong tenant ID here. So remember, this might either because I made a mistake or didn't fill it in properly, or because there's a hacker was trying to change things around here. Let's just see what happens if I run with that change, and I'll just have to rebuild quickly and get that deployed across. But what we should see is a complaint, an error message that's basically saying, hey, I couldn't get hold of this authentication, this Azure Sphere device certificate on which all of the authentication rests. If I don't have that, then DPS won't trust me, my backend services trust me. I basically can't do anything useful. So let's just see if that comes up. And in a moment, we should see a message indicating that that has not been allowed for us today. Let's see, it's just taken out. There we go. So this time I got this error message saying device auth not ready. So that's basically saying, hey, I don't have this certificate yet, and I'll keep retrying, but it's not actually going to get very far because I've made this, this error, or this attack has been thwarted. Similarly, let's just suppose I end up trying to talk to some different URL than was allowed. I'll make a simple change. It doesn't really matter how much of a change I make. Now I'll get a slightly different error when I deploy, and again I'm going to see that I have been unable to make connection to this hub because the Azure Sphere OS firewall essentially said, hey, no, this app isn't allowed to talk to that URL, so I'm going to be prevented from doing that. So let's just see if that appears in the debug. And I think at that point, we'll be pretty much ready to wrap things up for the day. So we're starting up, and then actually just whilst that's loading, again, just to point out, as I was saying, with IoT Central, we have the similar instructions here as linked to from our docs and from GitHub, which allow you to talk through again. So the UI is a bit different, but the fundamentals are the same. So if we come back here one more time, we can see the app is now just starting to run up, and we'll see that this time we were okay. We could talk. We found out which hub we should talk to, but notice we're not sending any telemetry yet. And I think very quickly, yes, I get this result now saying there's no network. So as far as the IoT Hub SDK is concerned, it doesn't have network to talk to, and that's actually because the Azure Sphere OS firewall has prevented that. So I think that about wraps things up of all the things I wanted to cover with you today.
That was a great overview, Richard. I always like to have at the end time set aside for folks to have their last tidbit that they want to let developers know about. So what would be your top tips or important information you would like to share with developers who are building devices with Azure Sphere?
I guess it would be that just to go, as I say, we didn't spend so much time with it, but do take a look at what we've got on our GitHub samples repo, and just all the different apps we've got there for showing you how to use all the different peripherals. And we also have these things called reference solutions, which actually are sort of larger building blocks that tackle a particular problem you might have, such as how to get a user connected to Wi-Fi. So obviously I use the CLI to get connected to Wi-Fi today, but that's not going to work for an end user. So we have some things to help you with that. And also we have some reference solutions that help you work with adjacent MCUs. So you might be building a device with an Azure Sphere chip and another MCU, and things like actually you can use Azure Sphere to also upgrade the firmware on that attached MCU. So we've got some cool things there if you want to go check that out.
Thanks so much, Richard. And I can definitely, say with the samples, they're really great to get started with. We've used a lot of them, especially the one with IoT Central in the classroom when training, and you can get up and running quickly, especially with connecting to IoT Central or IoT Hub with Azure Sphere. So thank you so much for giving this overview. So let's go ahead and jump into the resources so folks who are watching know where to go and ask questions. So the first big place is really the Azure Sphere docs and where you get dev kits and the samples. So here are some 3 links to know about for docs. That page that Richard was showing earlier that shows our dev kits that are available at this moment, and then the Azure Sphere samples. Another great location that we just that's a little bit new is Microsoft Learn. We have a lot of hands-on tutorials on Microsoft Learn, and we just published some for Azure Sphere. We have an example for IoT Hub, and we have an example scenario for IoT Central with Azure Sphere. So check that out. We'll put all of the description. And then I would hope you know about IoT Show because you're here. But I just wanted to point out that IoT Show, we have a lot of different formats. So we have, these deep dives where we bring in speakers like Richard and myself to go over a technical walkthrough. And then we have Olivier, who runs kind of the classic format where we talk about what is the latest announcements and do these partner spotlights. So definitely check that out. Another place for you to check out is the Microsoft tech community. So we have a community for IoT, and the URL is down there below. So if you have Azure Sphere projects, we have a conversational space about Azure Sphere there. So we would love to see your projects. We would. It's a great place to see blog posts. We post a lot on Azure Sphere on that channel, and then it's also a great way to meet other community members and ourselves because we're there looking at people's projects, answering questions. Another great place is the Microsoft Q&A site. We made this live during build. Think of it kind of like a Stack Overflow, but on Microsoft. Even though we're monitoring Stack Overflow, but we're on Microsoft Q&A as well. So if you have questions about Azure Sphere, when it could be technical questions, it could be business-related questions, support questions, go to Microsoft Q&A. And we also have a URL if you have Azure Sphere suggestions. We want to hear them. If you really want to go on user voice because, for example, what Richard highlighted earlier with unclaiming or claiming as a feature, and you want to see that happen, share that feedback with us. We really want to hear that, and that way we can continue to improve our products. And then the last two links are going to be talking about a little bit more about security. Links are highlighted. They're the 7 properties and then the 19 best practices. So 7 properties of highly secure devices. So check out those links below. So huge thank you, Richard, for taking the time out, joining, helping to answer some questions, and thanks everyone for tuning in. We hope to see you at the next deep dive. Thanks everyone.
Thanks, Pamela.
Bye.
Bye.